Alright, so far we have seen how we can use Microsoft Excel for developing and solving mathematical models, and we could relate input variables to intermediate variables, then on to output variables. With Excel, once you set up your model, you can find what effect will changing an input will have on the outputs. So such kind of playing around with data is essentially what we call as what if analysis, changing inputs to study the effect on outputs. We could also set the output to certain value and try to work backwards to see what inputs will get us that output. Such kind of analysis is called goal seek or goal seeking. Now, Excel can also be used for another type of goal seeking analysis. In this goal seeking analysis, we start with the output variable, but instead of specifying an exact value that we want to achieve, we could simply say that we want to maximize this variable to the extent possible and subject to certain constraints. Now, these kind of problems are called optimization problems, and Excel is very well set up for modeling, analyzing, and solving optimization problems. Optimization is a technique typically taught in math classes, and it there are various ways of solving optimization problems, and depending on the relationship between the inputs and the outputs, the solution approach will differ. If the relationship is purely, let's say, a linear relationship, we can use what's called a linear programming approach. If the relationship is not a linear, we could use what's called non-linear type programming approach. And or we could simply try and solve optimization using analytical methods such as calculus, differential calculus. In this class or in this session, we will only see how to use Excel to solve linear programming and integer programming type problems. Well, with most models, for most decision models, we want to start with understanding the problem and coming up with a mathematical model that represents the problem, and then implement it in spreadsheet and then analyze it to see how inputs affect outputs and so on. We'll do the same thing with optimization also. Imagine there is a company that makes hot tubs. It's called Blue Ridge Hot Tubs, and they make two types of hot tubs, Model 1 and Model 2. And the models give different rates of profits. Model 1 gets $350 profit per unit sold, whereas Model 2 gets only $300. Now they want to make certain number of Model 1, certain number of Model 2. But to make bathtubs, you're going to need pumps, you need shell and tubing, and also you're going to need people to work on it, labor, to put them all together. So now with this hot tubs problem, to make one of Model 1 type, it's going to need one pump. It's going to take 9 hours of labor, and it's going to take 12 feet of tubing. Whereas Model 2 takes only 6 hours, but it takes more tubing. Both models use one pump each. The business that we have, Blue Ridge Hot Tubs, it has limited amount of resources. It doesn't have infinite number of pumps. It has only 200 pumps available to them in inventory, and the labor they have is also limited. We have only 1566 hours of labor available, and tubing is also limited. Less than 3000 feet of tubing is available. Now with these constraints they want to maximize profits. Okay, and how will that work? Of course we want to try and find out what the problem is. The problem is that we want to maximize profits, but then the variables that we want to find values to is M1 and M2. M1 is the number of model 1 hot tubs to be made. M2 is the number of model 2 hot tubs to be made, and we are trying to maximize the profits. Okay, because we get $350 from M1 and $350 from M2, the model 2. So the profits is 350 M1 plus 300 M2, and we want to find out what that M1 and M2 values are. Now of course we have some constraints such as that the number of pumps can't be more than 200. So one pump per model 1, one pump per model 2. The total number of pumps needed cannot be more than 200. Has to be less than 200 model equals pumps. Similarly, labor, we could take 9 hours of labor for model 1, 6 hours of labor for model 2, and the total amount of labor that you can use has to be less than or equals the labor available. In tubing, we take 12 feet of tubing for model 1 and 6 feet of tubing for model 2. The total number of tubing available is 2880 feet. So these are the kind of physical constraints that we have to work with. In addition, whatever solution you come up with must make sure that both models, the number of tubs to make has to be 0 or positive. You can't have negative values for M1 or M2. So that's another constraint. In addition, both M1 and M2 must be integers, which means you can't have fraction of hot tubs. It must be exact integers like 1 or 2. It can't be 1.25 or anything like that. Alright, so the problem in mathematical terms can be represented as this: maximize 350 M1 plus 350 M2 subject to these 1, 2, 3, 4, 5, 6 constraints. Now these 6 constraints, of course, if profit is the maximum, it's a motive, how do you go about solving it? Alright, now what we do is we kind of use Excel to set up the relationship between inputs and outputs, then let Excel solve it for us. So in Excel we will set up these following areas: constants, constraints, variables, calculations, and objective functions. Okay, and then we will solve it. For this problem we will create a spreadsheet like this. We will have all constants all shown in one area, and the variables that we want to play with in another area. Just to distinguish one area from another, I use a different color background. Calculations are intermediate variables that are going to be used. Objective function is the total profits. And let's go ahead and do this spreadsheet quickly, and then we will see how to solve this. Alright, now that we have our spreadsheet, let me show you what I have here. We have the constants in sections A2 to C7. These are all simply numbers, and the variables that we want to play with are how many hot tubs make. We want to make model 1, model 2, and so we have, these are the constants, these are the variables to play with. Then we have calculations, which are basically intermediate variables, and we want to make total profits is simply a sum of the product of number of models to make and the profit going to make. So I'm using the sum product function. It's simply specifying 2 arrays. The first array is the area where the 2 variables are, and second array is the area where the 2 profit numbers are, and that tells us that with one making one model of one of model 1, one of model 2, you get $650 profit. If I make two of model 1 and one of model 2, that's 2 times 350 is 700, plus 1 times 300 is 700, 300. 7 plus 3 is $1,000. Okay, so in other words, I have a formula for total profits. Number of pumps required is, again, the number of pumps is given as 1 for model 1, model 2, and these are the models, number of models we're going to make, number of pieces. And labor required is again given to us as 9 and 6, 9 for model 1, 6 for model 2. And so total labor required, I have a formula for that. Tubing required is, again, we have a formula for that, which is again, I'm using the sum product, which is 1 times 12 plus 1 times 16 equals 28. Again, if you notice, I'm using B2 to C2, B12 to C12, that's my variables, and B7 to C7, that's my constant. And overall profit is given by B15, which is the total, just simply reflecting what's in B15. Now I also have constraints set up. Constraints are uh, set up as pumps available, labor available, and tubing available. These numbers are already given to us. Now we're going to try and build a relationship between these two. I mean, we want to try and manipulate model these two numbers so that this number is maximized. Okay, if I do something like this, if I do 200 here and 0 here, that will be, maybe that's the maximum number of model 1 I can make, because model 1 gets me $350. If I make all model 1 type bathtubs, I'm going to get $70,000 profit. But the number of labor required is going to overshoot, because available labor is only 1566, but whereas I'm going to need 1800 hours of labor. And so obviously this 200 0 is not going to be a viable solution. Maybe 150 and 50 may be a different solution, and again I can try and see how best it can work out. And again, the labor required kind of has gone up over the limit. 1566 is available, whereas if I do 150 and 50, you go over the available labor. So in other words, there are various possibilities. If you do 100, that will be a different number, and we don't know whether that is the optimal solution or not. Okay, so that's where Excel comes in. Excel is pretty good in figuring out a value for these two numbers, so that the final result will be the highest possible. Okay, and so that's where solver comes in. Now to use solver, we go to the data tab in Excel, and then under, you should see something called analysis tools. Now if you don't see analysis tools in your Excel implementation, it may not have been activated. So what you would want to do is you would want to go into Excel menu, uh, Excel menu. Okay, here it is, file, and go to options. Under options, go to add-ins, and add-ins, you would see active add-ins on top and inactive add-ins at the bottom. And right now analysis tool pack is already an active add-in. In your case, if you didn't see the solver, you'll probably see it here. You would then pick that from here and click go. That will then take you to a dialog box where you can then check the solver add-in dialog box and click OK, and that will make it available. Alright, so you want to make sure solver is available. And next thing is we want to try and model this. So go ahead and click on solver, and now the solver kind of comes up with a dialog box. Now this dialog box basically wants us to know where what variable is, and objective is what you want to maximize. The objective function in our case is the total profits, so which is in this cell. So simply go ahead and click on that. Then B21 is objective, and by changing variable cells, that is the set of cells which we want to manipulate, and in our case they are in these two cells, B12, C12. And Then what else do we have? We have some constraints, so we need to then specify the constraints. All right. First you go ahead and click add constraints. Then no constraints to begin with, go ahead and click add. So we're going to add one constraint at a time. First constraint is going to be between um, let's say the pumps required versus pumps available. So pumps required is 200. That number must be less than or equals pumps available. Okay, so B16 must be less than or equals F4. So that's the first one. Second, labor required must be less than or equals labor available. Tubing required must be less than or equals tubing available. And one other thing is, we know that both M1 and M2 have to be positive or 0. So these two numbers must be greater than or equals 0. And finally, these two numbers must be integers. So pick those, and one of the conditions is int. And so we added all the constraints. Click OK. Click OK, and just hitting cancel here will take you back to the dialog box. There you are. Now all the constraints have been added, and we are ready to solve the optimization problem. What we do is, it's going to use a method, an algorithm, and for now it doesn't matter. It's a simple optimization problem. You can choose nonlinear or simplex method. That'll work just fine. And we'll pick then go ahead and click solve, and what it says is solver found a solution, and the solution constraints are optimally and satisfied. And so once you found a solution, we can say keep the solution. And you can also see the reports. So let's pick up one of the reports, answer reports, and return to solver parameters. Click OK, and there you go. So the best profit you can make is if you make 122 of model 1 and 78 of model 2. And since I also want to see the report, you get to see the report here. There you are. And so this is a found a solution that using that particular method, and took less than half a second to solve it, and it just did 2 iterations and came up with the answer. And we have a total profit of 66,100. All right, very good. And in terms of constraints, we have number of pumps required. We used up all the pumps, so that is binding. And labor, we have 1566 available, and did we use all 1566? We did, so that is also binding. Tubing required, we used 2712, whereas we have 2880 available. Okay, so we didn't max out the tubing, but we maxed out the pumps and labor. Anyways, this is how one can model and solve optimization problems in Excel. Alright, so the rest of the presentation kind of goes over how it's done. And since the problem here was between allocating resources between two different options, two different variables, these two variables can be represented on a two-dimensional graph like this. And if you have 200 pumps and you want to distribute between model 1 and model 2, you could do 200 for model 2 and 0 for model 1, or you could have 200 for model 1 and 0 for model 2, and or any number in between. So the any number in between, you will have used 200 pumps. And add to this line, if you add a line for labor, we have a line that's a different slope. And then we add another line for tubing, which is again a third line, which is a different slope. Now all these three lines don't always merge at the same point. If they all merge at the same point, then you would mean you get the best possible values. But as you could tell, the lines are not exactly meeting at one particular point. But among these among the a points where they meet, we could find which is the best um, option. All right. Okay. So this kind of optimization technique is easily implementable in Excel, and it can be useful in many different situations, such as product mix and or doing job assignment to machines, or logistics and routing problems, or even financial planning when you have a portfolio management problem where you have fixed amount of investment dollars and you want to allocate it between different kinds of options such as stocks, bonds, etc. Then that can be an optimization, resource allocation problem. All right, so that's the end of this presentation. Hopefully it was useful to you, and if you have any questions, feel free to contact me. Thanks.